In this series of videos I'm attempting to repair and restore this HP9862A plotter. In the videos in this series so far I've dismantled the unit, stripped it down to a bare chassis, and I started to reassemble it, found various faulty hardware parts, so I've been repairing those as I've gone. I had to make some missing parts, which I did in the previous video, and it's now all assembled as far as the mechanics go, apart from the platter and the top shroud. And what I want to do in this video is start looking at the electronics. Now, these are very interesting machines from the electronic point of view, in that they, although they kind of have a processor, it's not a processor in the normal sense. It's really a kind of a sequence generator, and although it has a ROM, the ROM's only really used to provide particular sequences of bits and bit values within a given sequence, and so it steps through various sequences of events depending on the particular mode it's in, and then that fulfills a particular function. But it is very clever in the way that it interpolates values to plot the whatever you want to by just sending it coordinates. So the way this works is you send it a command to raise or lower the pen, and then you send it sets of coordinates, and each time you send it a new coordinate, then the plotter will attempt to drive the pen from the current coordinate in a straight line to the new coordinate you send it. And it scales the plotter platter in values from 0 to 9999, and it takes BCD values rather than binary through the command port on the back. So we'll look at that later on. But you can scale the drawing area in both the X and the Y directions, so you can effectively define your own space to suit the particular size of the paper or the area that you want to draw the chart on. So it's very clever, but that's all taken care of in kind of a hard-coded way. There is no firmware in this as such. There is what you might call firmware in the ROM, but as I say, it's just really a sequence of steps. So with that in mind, the next question is, how do we start investigating the electronics? Now, I've been through the power supply, and so the next thing I did was to get the motherboard diagram and start going through this. So what I did is go through this, and if you look at the you probably can't see, but each of the connectors on the motherboard, we have a designator here saying what should be on there. What I was looking at initially was the power supply values. So for example, plus 5 volts, plus 5 volts, plus 19. One thing I did find a bit strange on here, and if you are designing equipment, maybe something here wasn't quite how I would have designed it, and that if you look at the pinouts for these, the bottom right connector on all the boards is plus 5 volt, apart from one of them, which is plus 19 volts. So you don't want to mix these up, otherwise you could probably do quite a lot of damage. But it was kind of strange because there were some spare connectors. They could have rearranged these to put plus 5 volts on the bottom right of all of these, rather than having just one odd one, which is guaranteed to destroy a board if you plug it in wrong. Now, they are color coded, but even so, it seemed a bit of a strange design choice. So just make sure you plug the boards into the right slots. So I tested all these, and I expected them to be correct because the power supply tested good. So I tested these, and all the power connectors were fine. I tested the connections to the limit switches, the potentiometers, and the motors, and they seem to be fine. The reading sensible values, so just reading across the motor doesn't appear to be dead short, doesn't guarantee anything of course, and the potentiometers again seem to be giving sensible readings. All these supplies seemed correct. The connections to the front panel also seemed to give sensible readings. A couple of the pots did seem to be a bit noisy, so we'll have to investigate those later. I may have to clean those or replace them. But the next step, now I've tested the motherboard, is to start to look at the boards. And because, as I say, there is no central processor board, what I decided to do was to test the boards independently before I fitted them and look for any obvious signs of failure before I try to power this up. Because of the way these are arranged, it is possible to get a cascade failure if you get a fault on one board, so I want to avoid that. So what I started doing was taking each of the boards and looking at them one by one. So we've got the memory board, and luckily I do have the schematic for each of these boards. And so looking at this, we should be able to figure out if it's fundamentally working. It's not going to tell us if it works properly, but we can look for any obvious faults. And so what I was doing is picking each board and doing some basic checks, so really just checking across the plus or minus rails, looking for anything that didn't look quite right. It won't tell you for sure if it's working correctly, but we'll come on to that in the next step. So what I was doing was taking the board, getting the multimeter, somewhere you can see it, and then measuring across the rails. So here, if we look at this particular board, I know there's a fault on it. So if we measure across the ground and the plus 5 volts, you can see we're getting 9 ohms. Now, it will vary a bit, but 9 ohms is way too low considering what the schematic is showing. So it's just a collection of 7.4 TTL chips on here, and there's not that many. And so looking at this, you'd expect it to have a resistance of maybe nearer to 150 ohms to 200 ohms. So 9 ohms is way too low. And if I reverse the leads just to make sure we haven't got some sort of hidden diode in there, you can see it's the same in both directions. So we have an issue with this board. And what I do when I find something like this is I hook it up to the bench supply and see what current it draws, because it could be something active, but it's unlikely. It's most likely one of the devices is faulty. So what I'm going to do is go through, see if I can find the faulty device and replace it. So I'll do that on this and we'll see if we can figure out exactly what is going on with this one, and I'll get back on camera and let you know what I found. Okay, so after a bit of investigation, I found there was indeed a faulty device, so I've replaced that. And if we now measure across the rails again, notice we're now getting 144 ohms, which is more like what I would expect to see. I'll reverse the leads and we should see something similar. So that looks far more like what we would expect to see. So I've done this for all the boards, and I found 3 boards that were causing a problem. There was this one, we then had another one. So this is, and I said I do have the schematics for each of these. So the first one's the memory board. We then had this one, which is the qualifier flip-flop board. So this is kind of the logic, the thinking part of the machine. It's what makes the decisions. And that has a similar problem. This is reading 2 ohms, so I suspect that may actually be a faulty cap rather than a device, because that's too low a value really for it to be a failed IC. It could be, or it could be there's more than one failed IC. And then the final one was the the DAC, and again I'm getting a similar sort of reading on here of about 6 or 7 ohms. So I suspect we've got a faulty device on here as well. So what I'm going to do is go through these 3 boards, try and find where the short is coming from, replace any parts that I need to, and what I then do is hook them up to the 5 volt bench supply, and that will as a standalone board. So I'll just hook this directly to 5 volts on the 5 volt rail. And then what I'm looking for is excess current, so when it goes into a more active mode, to see if there's any sort of stuck bits and excess current trying to drive various gates. Once I've done that, I start fitting them all into the machine. Slow the light. And I power it up, so I fit the boards, or I was fitting the boards in such a way that as I fitted each one, I tested the current that was being drawn, and if the current spiked and there seemed to be no particular reason for it, then I'd take the card out and investigate it. The last card I fitted was the driver card, so these two boards are needed because they're part of the power supply, and the board on the left is the interface, so you can leave this one out to do the initial testing, but the rest you do really need them all in for it to really do very much. So as I said, this one is now the next to be fitted. I've got rid of what I think was the short, and I can fit this, check the current, and go from there. So I'll do this with the rest of the boards. There's only two left to go through, and then get back on camera, and we can try to actually power this up. If I do find something that appears to be particularly bad or interesting, I'll get back on camera and show you what I find, but it does appear at the moment we've just got a few short circuit TTL gates, and once they're sorted out, we can get the thing powered up and see what actually happens. Okay, so that's the last of the obvious faults found on the boards, and one of them was a faulty input, so that would potentially have damaged one of the other boards, and the other board that was damaged, it wasn't the matching one, it wasn't the one that was feeding it, so this approach can often save you a lot of problems in not damaging other components. So we'll get this board refitted. They are colour coded, and notice the two on the right are both purple. So there's a DAC for each of the two channels, the X and the Y, and although the boards are the same, it's best to keep them in the correct order because they will have been adjusted for that particular channel. There's a pot at the back that's used to adjust them, and you don't want to swap them over, otherwise you'd have to recalibrate them. You might have to do that anyway, but you definitely would if you swap them over. Okay, so we'll get this installed. Nice and tight. I have replaced the foam that's on the underside of the top cover, and now that all the boards are in, we have no more excuses. We need to get it powered up and see what it does. So without further ado, we'll get it closed. I'm going to run it from the bench variac. Okay, so right, let's move it back so you can see it more clearly. I'm going to start it on a fairly low voltage. Now it's not going to work properly at low voltage. I'm just going to turn it up to maybe 20 or 30 volts and look for any excessive high current, but then I'll need to go up to a higher voltage fairly quickly. I don't want to run it at kind of an intermediate voltage too long, that could damage something. So if I don't get a current spike when I first turn it on, I'll quickly ramp it up to maybe 160, 170 volts, which should be enough to bring it to life, and then we can start seeing what it does. Hopefully it'll come to life. If not, then we'll start fault finding. As I say, I do have all the schematics, so we can go through it. And this sort of thing is quite easy to work on. All you're doing is looking for a certain sequence, and if the sequence isn't working, you can investigate why. Okay, so let's get this powered up. Turn that one off. Go up to 40 volts. Turn the plotter on. This is where it says online. I think it's just an on-off switch. Okay, so that doesn't look too bad, and now we'll turn it up. So at just under 190 volts. The line light has come on, so that's quite promising. So we'll press the chart hold down. The chart hold is kind of also a logic lockout for the system, so it needs to be down for it to do anything. I don't have the platter plugged in, of course. I want to keep an eye on what's going on inside. So the first thing I'm going to do is try the pen up and pen down and see if anything's running at all. It hasn't moved. I was expecting it to do something, but it's hasn't moved at all. So we'll try pen down. lower left and upper right buttons allow you to set the bottom left hand corner and top right hand corner of the plot area. So if I push the lower left button, I would expect the plotter to move, which it is doing, so that's quite good. Not only that, but it's moved quite smoothly. We can then adjust the position, which we can, and this sets the 0 point for the plot chart area. So that's looking quite good. It's quite smooth, jumpy in places, but I know a couple of these parts, especially this right hand one, is very noisy. Okay, so I'll try pushing the pen down and see what happens. And it stays down this time. Pen up, pen down. Okay, so that's doing what it's supposed to. Okay, so I've been moving this back and forth for a few seconds and it doesn't seem too bad. It is it's noisy in places, but it's getting better as I'm using it. This hasn't been used for a long time, so I suspect there'll be a bit of dirt on the pots and the sliders. I have cleaned the sliders, but it does need a bit of use. Okay, so the next thing to do is I'll turn these down. I'm not quite sure where they're, because I've been playing with these, so I'm not quite sure exactly where it's going to drive to. And if I push the, in fact, I'll try pressing the pen down button. I think it should stay down this time, which it does, and up. So that's now working the way I would expect it to. It's not actually moving this because there's no spring pressure pushing this down, but you can see that the control plate is moving. Okay, if I push the upper right button, then it should drive up around here somewhere. Okay, so we've obviously got something sticking. Okay, so it looks like the belt is too slack, although I think we were wound off the end of the travel, so as I say, I have been turning these, so it wasn't adjusted correctly. Okay, so we'll try the pen lower again in that position. It's grumbling a bit, so we do have a bit of work to do. And it looks, as I say, I think the Y cord is way too slack, and the motor is turning, but it's not moving the carriage, so, well, not smoothly enough. So I think that needs the belt tightening. Apparently, what you have to do is take it out and retie a knot in it, which seems a bit of a crude adjustment, but that's what I'll have to do. It is loose. I can feel it's loose, and I try pushing it, so that's not that surprising. So we'll go back to the lower left. Okay, well, it's kind of a little bit jerky, and I suspect it just needs the potentiometers and the pots cleaning a bit better, so I'll get onto that, and also I will look at retensioning the Y cord. I'm not going to do that now. The next thing I want to do is see if we can hook this up to an external controller to see if there's a way to control this through the in-out port and see if that actually works. And once I can get to that point, then I can start to write a simple program in the test controller to exercise this and maybe help to free it up a bit. I think if it's just used a bit, then it should free up, and that in conjunction with cleaning the pots, I think it should come back to life quite well. But the next step is I'll get one of the controller boards that you've seen in the past, that's one of these, and I'll get this configured to hopefully drive this, and then we can write some firmware for it and see if it works. I'm doing it this way rather than connecting this directly to the calculator, simply because I want to be able to control it without having to figure out if the calculator itself is working, and also how to drive it through the calculator. So doing it this way will allow me to write very specific test programs for it and drive it through various different tests without wondering if I've got a problem in the program I've written for the the calculator. Okay, so next thing is I'll figure out how to get this hooked up. Well, I tried driving the plotter using the PIC controller and had a very simple piece of code in there just to raise and lower the pen. The command sequence for the plotter is quite simple. It's just a 4-byte sequence that you need to send it, and there are some handshake lines that control how the data is transferred. But as soon as it saw the first edge, the error light was coming on, and I double checked that the lines were in the correct state, and they were. So this tends to indicate that there's something wrong with the sequence. It's not seeing the correct start of sequence, or it thinks it's part way through a sequence. The error light comes on if the plotter thinks that the data transfers out of sequence, or if it detects an overrange or underrange value coming in from the in-out port. Or at least it does if it comes on in response to an edge on that in-out port, which is what it was doing. So as soon as it saw the first edge coming from the PIC controller, it then threw up the error light, and that locks up the machine. It won't do anything beyond that point. Incidentally, to connect this to the plotter, because I don't have the proper interface for this machine, I just made up an interface connector, and this uses standard connectors such as you'd use on an Altair machine or something like that. And then I have these interface connectors that I use for the Altairs as well. And so you can just make up a simple connector, and then I can connect leads to this, and then this connects through to the PIC controller. Okay, now that wasn't working. It was showing me an error every time I tried to start the PIC controller. So I started working my way through the electronics. Now we know that the servo works, we know the counters work because it will drive successfully using the upper right and lower left buttons. So that's all working. It seems to be working as far as the analog's concerned, but it's not taking in data properly from the in-out port, so the interface system's not working. Now initially I suspected it was the in-out card, but this is working fine. So this is quite an easy machine to work on up to a certain point, because a lot of the boards are kind of self-contained units to a certain extent. So for example, you look at something like the interface board, so this is for this board at the end here. You can just power this up direct from 5 volts, and then you can just set the input lines. And again, because the connectors are fairly standard, you can take something like this, put some jumpers onto it, and then use a breadboard to do some static testing on these boards. And you can do that for most of the logic boards in this, because although some are more complex, this is slightly more complex, it's still very easy to drive it manually, and that's what I've been doing. So I now have the in-out port hooked up to a breadboard. I'll show you that later on, but I've got it configured so I can manually send it commands using a couple of push buttons on that breadboard. As I say, I'll show you that later. But it allows me to have very tight control of what the plotter's doing and send it very specific commands, and that way I can kind of work my way through the electronics fairly easily. So we've got another problem on this board, had a problem with this one already, and there's another device that's not working correctly. So I'm going to work my way through the electronics, and as I say, I'm sending it specific sequences. This is one of the advantages in using a manual drive approach to control something like this. It takes the complexity of messing about with a calculator and programs and everything else out of the loop, and you can just send it a very specific command, and that way you can determine exactly what's going on within the control loop. So a very interesting machine to work on. It's very fascinating the way they designed this. It is just a sequence generator, but it's a very clever design, and it's even if you don't have one of these, I still recommend, if you're interested in this type of electronics, to get a copy of the service manual, which you can find fairly easily online, and just look at the schematics in there. It is a very interesting design. Okay, so I'll get the rest of this done and then get back on camera and see if we can get any further with it. Okay, so I found a total of 6 failed devices, so I've replaced all those, and the basic idea here was to get the interface working. It was just completely ignoring the control card that I was trying to use. In fact, it wasn't really ignoring it completely. What was happening was it was coming up with an error every time any data was sent. So the transfer for this machine from the calculator is quite simple. It's just a 4-byte sequence that needs to be sent, and there are 2 handshake lines. So there's like a flag that comes from the plotter to tell the calculator that it's ready to accept the next byte, and then there is a kind of a read and write line from the calculator to tell the plotter that there is now new data on the 8-bit data bus, and the control sequence is 4 pass for whatever you're doing. So it all sends 4 bytes in sequence, and the 2 handshake lines choreograph that exchange. If that gets out of sequence, there's also another input that tells the plotter whether it's the first of those 4 bytes or one of the remaining 3. And that's how the plotter determines if it's out of sequence. And if it goes out of sequence, then the error light comes on. I'm not quite sure if you can see the error light. It's not switched on at the moment. But if this error light comes on, it means that the plotter's not happy with either the data that's coming is out of range, or the sequence is incorrect for the data that's being transferred. Now, rather than use the PIC card at this point, because I was having so many problems with the electronics, it was working internally. It would drive from bottom left to top right. The pen down, pen up worked, but it would not accept data through the external port. So what I decided to do was just go to a manual approach. You can drive this manually to a certain extent, just to send it basic commands, and that's what I'm doing here. So I'll move the camera in a little while to show you what I've got hooked up, but it's basically 2 buttons and some jumpers, and the jumpers allow me to set the data value I intend to send to the plotter, and then the 2 buttons are on the one's on the sync line. That's the one that determines if it's the first byte out of 4 or one of the remaining 3, and then the other button is on the write line. That's the control line that tells the plotter data is available. What I should be able to do by manipulating those in the correct way is send data values through to the plotter. The scope is hooked up to those 2 lines. One's on the flag, so the yellow trace is the flag, that's the I'm ready for data line from the plotter, and then the other trace, the blue trace, is the control line, the signal that tells the plotter to read the next data byte. So what I'll do now is I'll power up the plotter. Okay, so what I have to do, I've got these buttons wired up in reverse to cut down on the switch bounce. If I try having them the other way around, because I don't have any debounce circuits or anything, it's just wired directly to the switch. There is a resistor and capacitor there to try and debounce it a little bit, but I found that it was still seeing certain key presses as double presses, and it was causing the machine to misbehave. So what I'll do is I'll restart the plotter with the 2 buttons held down. You can see on the scope that we have the control line high and the flag line is low. So the flag line being low indicates that the plotter is ready for its next command. In this mode, I should now be able to drive the plotter to its lower left or top right positions. Which I can, and I should now be able to send it a sequence of 4 bytes. So what I do is I send it the first one. So that's the first one sent. You can see on the scope I sent it. I now release the sync button and send it 3 more. And you can see when I said it the 4th one, the error light came on. So we know it's now working as far as the sequence is concerned, and I should be able to make the error light go off by sending it a correct sequence. So I'll send it the first byte, and now the error light's gone out, so it's got the correct sequence. What I'll do now is set a value, and incidentally I've got it configured to send a position command, not a pen up or down command. So what I can do now is set a value on the data lines. It's currently set for 0, so it is staying in its 0 position. But if I change one of the jumpers to set a different value on the data line, it should now cause the plotter to drive to a different position when I send it the next command sequence. So I'll go through the command sequence of sending it 4 bytes. And as you can see, it's successfully driven to the new position. And what you can do is set whatever command value you want on the data lines, and also you can set the pen control as another one that controls whether the command is to lower or raise the pen as well. And you can set the values to whatever you want and send it a very explicit command. And of course that's much more straightforward than trying to figure out the interaction using something like a microcontroller. So what I'll do, I'll just move the camera so you can see exactly what I've got hooked up on the back here. Okay, so I've got the interface card, and the interface card itself is just made up from a standard connector and one of these connector cards. And this is what's left over, but it's a 22-way connector. I will make a housing for this that allows me to plug it in as per the original design, because I don't have the proper cable for this. And this is then connected through to the breadboard. So I have the data lines. I'm taking power from the calculator because we do have the +5 volt and 0 volt coming through to this connector. And then I have just the 2 buttons. As I say, one is on the sync line and one is on the control line. And then I've got a pull-up resistor and capacitor to debounce and to give it the correct levels. And then by manipulating these I can send it the 4-byte sequence, and by setting the correct values on the pen control line and the 8 data lines, I can send it whatever command I want. So I can drive it to any position, I can control the pen, and it's far easier doing it like this and sending it specific commands, because it means I can test every board and every sequence individually without the complication of trying to figure out where I am in the sequence, or if there's an interaction that's not working between the two. Once I've got all these working, the next step is to reconnect this. Now the boards are working, it should work, and so in the next video I'll get some code into this and we'll try driving the plotter in a more dynamic way. And if that works, I can then move on to getting the platter working and hopefully getting the problem with that resolved.